We all probably went through this early on in our coding journeys. You build a nice, simple, static website using some basic HTML and CSS beauty, maybe sprinkle in some of that JS spice, and start feeling that dopamine rush, with the achievement of creating something from the ground up still fresh in your mind. But as humans do, you begin to look for the next project. You start to strive for even greater things. Surely you can stay at that basic level, but with great projects come great responsibilities, one of which, and a major one at that, is the tools you choose to bring your metaphorical child to its full potential. And like clockwork, a tiny little devil appears on your shoulder and starts whispering things, awful things, disgusting things. Like, after all, why shouldn't I use a framework for that? I hear React is nice and light. Or, I definitely can't make a REST API from scratch. I need something to take care of all that boring low-level stuff. And also that middle-level stuff. And maybe some of that high-level stuff as well. After all, I don't have all the time in the world. And so you end up on a downward spiral, cursing the industry and its standards along the way, barreling towards the inevitable end of forsaking it all and becoming a goose breeder or the like. Well, I am here to act as the counterbalance to those deplorable ideas and bring forth the one truth of programming. If it's Turing complete, then it's enough, no matter the task, especially if that task involves Doom. And do you know what happens to be Turing complete? Well, if you happen to take a look at the video's title, you may infer I'm talking about Bash. Yeah, just Bash. Nothing else. I'm making YouTube from scratch using that. That's gonna be fun. Well, I should probably get into the thick of it, as it's quite the adventure, I must say. First off, I want to make amends with me from a minute ago. See, frameworks are not so bad if they are made properly, I'll give me that. But also, I think we all know that the only good code is the one you write at that given time. The moment someone else's dirty hands touch your creation, or more than a couple of weeks pass since you've completed it, it automatically becomes absolute garbage. And such, I immediately surmised my long journey will consist of multiple moving parts, starting with a full-on REST API framework made entirely in and for Bash. With this, I need to be able to define endpoints from which I can return different types of data, communicate with a database, and have a local storage system where user-uploaded files are stored. I decided to also make a simple HTML template engine, which would basically allow me to populate generic HTML files with custom data, depending on the page or other endpoint a user requests. I told you I'm doing everything in Bash, no exceptions. Well, maybe a small one, considering there aren't any browsers that display Bash source files as DOMs. So stuff that is necessary for the actual thing to be displayed in a browser window like HTML and CSS will still be needed. Hope you'll forgive my transgressions, oh Bash gods. And in the end, although realistically it's a thing done in parallel as the project grows, I'll develop the app itself, while trying to capture the main features of the platform I'm taking inspiration from, YouTube. Now, with this high-level overview done, let's start with first things first. Well, first there was darkness, then there was light. Then someone said, hey, we should make our own HTTP server. Then there was darkness again. I began by creating a simple server using netcat and redirecting its output to an external script to handle the reading and writing of the data streams. Netcat is a networking utility that handles reading and writing from and to network connections using TCP or UDP. It's a really simple tool that can do port scanning, listening, and file transferring, in addition to the basic transmission of data via the protocols I mentioned before. Also, as a bit of foreshadowing, its strength of being really simple to use if you're following its intended purpose means that straying from that will often come back to bite you. Just food for thought. Inside the script, I defined two major functions, one for reading the request and one for writing a response. An HTTP request consists of a request line which contains the HTTP method, like get or post, the target URL, and the HTTP version. A list of headers which are key value pairs separated by a colon that provide additional information about the request, with each header being on a new line. A blank line to indicate the end of the header section, and an optional body, present only for methods like post or put, containing the data being sent. Also, as a side note, each line, including the request line, headers, and blank line, is terminated with a carriage return followed by a line feed. Having these details in mind, reading the request boiled down to reading line by line. First parsing the request signature to get the method and URL. From the URL, I'd also get the parameters starting after the question mark and separated by ampersand, with each entry following the key equals value structure. Then processing the headers individually and storing them in an associative array, which is the bash equivalent to a map, although with the mention that it doesn't support nested objects, which surely isn't another bit of foreshadowing of my troubles. And finally, reading the body by using the content length headers value to know exactly the number of bytes I need to read. The response was basically this process mirrored. Create my own signature with the HTTP version and code, followed by headers, among which I include the content type so that the receiver knows how to render the data I'm sending. Then a blank line, and finally the response body, all done line by line. Up next, I began working on the basic flows that allow developers to register their own endpoints to be exposed by the framework. This first iteration was defined by the register endpoint function that would take the endpoint handler function's name and the associated HTTP method and URL and would create an entry in a global handlers array. I should take this occasion to also point to this fact, as it will be a reoccurring theme throughout, that in Bash there is a special type of declaration, namely using the N flag, which means the variable is a name reference for whatever string is passed onto it, meaning that it will look in the execution stack, respectively environment, for a variable or function with that given name, and will act as a reference to it, which is a really cool feature, but it also means you can't reuse names as it will pick the latest one defined, and also can do something like this, as it will be interpreted as a circular definition, because in the execution stack, the former declaration will be overshadowed by the latter one. But with this, after parsing the HTTP request signature, I can call the associated handler, passing onto it the URL parameters and body of the request. I also added a few methods to simplify the process of creating responses within the handlers. Then, to simplify the process of importing stuff between scripts and also give that feel of simplicity to an end user, I created a simple import manager that keeps track of all the imported scripts within the execution environment. With this, you simply need to source the root framework main script, and then have fun importing whatever you need using a really readable Python-like syntax. At this point, I'm barreling towards an intermediary goal of a fully functional JSON-based REST API. For this, I first improved on the controller side of things, allowing URLs to contain path variables, which meant moving away from the static declarations of strings and onto regex matchers, allowing me to extract and pass these variables onto the handlers. Additionally, now each endpoint declares its associated default MIME type, meaning the format of the resource it returns, so that the receivers can display them accordingly. As for the data itself, first off, storing it is done via the SQLite free CLI. To streamline this process, I created wrapper functions over these primitive calls, allowing users to create and clear tables, as well as declare, retrieve, update, and delete entries, with every method pretty much boiling down to getting the data as an associative array, which works perfectly if you do your job properly and your databases don't have nested objects, validating that data, then formatting it to match a database command or query, executing it via the SQLite free CLI, then getting the output and parsing it accordingly, finally updating the return value via name reference. Also, on the topic of data, to cover the JSON part of the JSON-based REST API thing I said earlier, I used JQ, a really light command-line JSON processor. Similar to the database stuff, I also created methods to simplify the use of the primitive calls and allow users to extract values, whatever type they may be, iterate over keys, and create JSON strings from associative or simple arrays. But following this, the project reached a stage where something useful can actually be done with it, a bash-only REST API. To show off a bit, I created a sample table of entries and went through all the possible operations one can normally do when using an API. And although it's not breaking any records, it's probably faster than most online newsletter websites, so I'll take it, even if I'm not sure that even qualifies as an achievement. And with this small dub in the bag, let's move on to the next checkpoint, HTML. As I mentioned previously, browsers, or rather any client in general, needs to know the type of content it receives, so that it can display it properly. And so I divert my gaze toward template engines, which is kind of like in between a fully dynamic front-end framework and static sources. The idea is that at runtime, the engine takes an HTML template, which is just an HTML file that may contain specific syntax defined within the engine, and replaces that with valid HTML after parsing it. It generally handles stuff like variables, functions, text replacement, file inclusion, conditionals, and loops. But in my case, I simply chose what I needed as I developed the pages, so I probably shouldn't call this a full-fledged engine. But I will anyway. In my case, I covered three main things, replacing some global definitions like the current domain, in this case the host IP, the app name, as well as the URLs to the storage and static directories, which, by the way, is a small hint to what is coming after this. Then, replacing context variables which are identifiable by the context root used when accessing them and are passed from the script to the template via JSON string. And lastly, handling for loops. I am making a YouTube clone, so it's pretty mandatory I can display lists of videos, and I'd rather not do them by hand. So I followed this syntax, inspired by Svelte, when parsing these. Instead of context, the root identifier here is defined by the loop variable, which iterates over the array defined by this JSON path identifier, populating the content represented by the loop block with properties of the current array element. Without getting too much into details, because it's on the same level of fun as regex, the one that did most of the heavy lifting here was sed, which is and also means, stream editor. And no, I'm not talking about Twitch VODs channels. Sed is used to parse and transform text. It has quite a few commands to go through, but the most used, and also the ones I needed, are the ones for pattern matching that display the line or lines of the content matching the pattern defined before the command, and the ones for pattern replacement. This one, although may seem alien at first, is defined as follows. First, specify the substitution command defined by the s at the start. Next, there are two sections. The first one defines the pattern for which the tool will look on parsing the incoming data stream. This is basically a regex pattern. And the second one is the content with which the matches are to be replaced. Finally, the last part contains the search specifiers, like if you want to apply this replacement to every match, you'd use the G specifier, meaning global. Of note is the fact that all these sections are separated by a delimiter. This delimiter can be any character, but you gotta make sure it's not gonna appear in any of the other sections, as the tool will simply consider those as delimiters and you'll end up scratching your head trying to understand why and how you just deleted half of your kernel's logic. Of course, this can be avoided by escaping special characters, which is easily done using, you guessed it, also sed. Now I sure hope this doesn't turn into a recursive problem. But following this, which was by no means a small feat, it's time for some real challenges. First off, uploading and accessing entire files, whether images, documents, videos, whatever your heart desires. The star of the show in this case is this simple keyword, multipart. By specifying the content type header value as multipart, followed by a boundary string, defining the start and end of the data to be transmitted, both the client and the server know to continuously read the incoming messages, reconstructing the file on either side as it is sent, stopping whenever a boundary is found. This is an example message containing multiple files, starting with the boundary string. Then each entry contains a list of headers with metadata about its corresponding file, stuff like name or MIME type. And finally, after the last entry, that same boundary string followed by 2 dashes, marking the end of the transmission. Well, knowing this, it's just a matter of reading line by line, then writing to a local file created with a unique name and corresponding extension, just like with a normal HTTP request. But there's a catch. As you probably know, not all files are text files, or rather have a proper textual representation, as not all bytes correspond to valid characters. And this means that methods like read, echo, printf won't work like they did before, as they are text-oriented tools and generally ignore unrecognized data bytes. Of course, this means that I just have to move away from those onto methods that work directly between files and data streams, in this case DD, meaning device drivers, which can do quite a bit of stuff as you might infer from the name, but it also works perfectly for my case, as it can be used as the driver to write from the input stream, in this case the one offered by Netcat via the main script, and write it directly into an output file, without a care for what it actually is working with. With this in the bag, I implemented some default endpoints corresponding to the file, storage, and static directory defined by the user, as well as some methods for handling these two storage types. Using these, you can easily access the exposed files, and though in this case it may seem like these two directories are identical in functionality, in an ideal world, the static files are always accessible and mostly intended for the front end, whereas the storage files have associated read and write permissions. But I'ma be honest with you here, I may be feeling a bit lazy in regards to auth this time around, although to cut me some slack, it wouldn't really be relevant to the core idea of the video. And now I can finally go on to creating the app itself, right? Look, I'll first go with a prototype and... Wait, why aren't the images loading? The requests are getting a connection refused error? They aren't even logged by the framework. Must be something wrong with the browser, I guess. Nope. The actual issue turns out to be the fact that Netcat can't process parallel connections. Trust me, I tried, and then decided to read the extra specification. Fortunately, there are alternatives out there, so I had options to choose from, and I ultimately went with the one that was the simplest in its implementation, yet could check this requirement, namely NCAT. Yeah, it's pretty much the next Pokemon evolution for Netcat, which means that adapting the script wasn't too much of a hassle. Except for one tiny thing. It all came crashing down the moment I tried to access an endpoint. Fortunately, the flood of error messages was all pointing to the same thing. Symbols not being found, be them variables, functions, or anything in between. But hey, that just means I have to export every important thing so that it becomes available to both the execution environment and its children. Well, in theory, that is exactly the fix. Except for one tiny, little, negligible thing. Arrays can't be exported. Yup, simple as. It's an array, well, better be sure you can't go writing export next to its name. Not that it'll crash. No, of course not. It'll just not do it, without even bothering to tell you, leaving you to figure it out by yourself why on God's green earth are the arrays always empty. Great, so the issue is here, and it's safe to say it's here to stay. So isn't there really anything to be done? Fret not, my child. Hidden, and I mean really hidden, is the P flag used in declare statements, which stands for print, meaning it prints to either stdout or a specified file descriptor the variable and its current value in the form of a declaration. When constructing the environment, I collect all the array declarations, write them to a temporary script, then simply have it so the HTTP orchestrator main script sources that temporary file to load the arrays into the execution environment. And now, sparing you the boring details, I used all the tools I had built up to this point to create a, I won't call it basic, but rather, let's say rustic, clone of YouTube that allows you to scroll through your homepage, search for videos, upload your own, and view them. Pretty much 99% of the actually useful stuff on YouTube. Although I'll say, aside from the view counter, it's missing stuff like a like and subscribe button, unlike the real thing. So, you know, if you like this, don't let those actually useful features go to waste. But all in all, aside from the HTML stuff, which still is processed via a custom engine, this whole entire thing is written in Bash. I don't know why you'd ever need something like this. I'm not even sure why I even made it. But now that it's here, I hope I managed to let the world know that Bash is still all you need in this day and age.